This is a circle. What is the dimension of the circle? If you answer a circle is two-dimensional, make sure to watch this video. A circle is not two-dimensional. A circle has an area, so it seems natural to think of it as a two-dimensional shape. But is that really the case? By definition, a circle is the set of all points at a fixed distance from a given point. Notice that the definition says nothing about the interior. In fact, a circle consists of only the points on its curved boundary. The inside is not part of the circle itself. The circle itself, the curved boundary, is what truly defines its dimension. Even so, you might still think of a circle as two-dimensional. A circle exists in a 2D plane. Every point is represented by two coordinates. Look at the equation. It requires two variables x and y. Since two symbols are needed to represent the point's position, it's easy to assume that a circle is two-dimensional. But the dimension of a shape is different from the dimension of the space it exists in. Just because a circle exists in a 2D space doesn't mean that the circle itself is two-dimensional. So the curve of a melting clock in this painting is not necessarily three-dimensional. For the same reason, the number of coordinates needed to express a point on a shape is different from the dimension of that shape. Just because something is represented with two coordinates does not necessarily mean that it's two-dimensional. The dimension of a shape is determined by the minimum number of variables needed to express the point's position. Look at the number line. Each point is represented by a single number. Its position is given by x of t. As t changes, x of t is determined one by one. Just as a straight line is one-dimensional, a curve is also one-dimensional. Look at the graph of the parabola y equals x squared. Each point is represented by two coordinates x and y. However, once x is determined, y is automatically determined as well. Y is not an independent variable. Even though each point has two coordinates, only one variable is needed to describe them. That is why this parabola is one-dimensional. The same applies to a circle in 3D space. Even though a melting clock is curved in 3D space, it is still one-dimensional. To show that the circle is actually one-dimensional, let's try expressing all points using only x. Rearrange the equation of the circle. Y is expressed in terms of x. Now, the point x, y is written using a single variable. But there's an issue. For each x, there are two possible y values. This means we can't uniquely determine every point this way. We need a different approach. It is to use this angle theta. From any point x, y, we can form a right triangle. The point x, y can be expressed as r cosine theta, r sine theta. Only one variable theta is needed. R is just a constant. Moreover, each point corresponds to only one theta. The points on the circle are perfectly represented using a single variable. Therefore, a circle is one-dimensional. The dimension is the minimum number of variables needed to express the point's position. I hope this video was helpful to you.